Hi, today we discuss about the scan operand for positive signal edge and what the difference between P operation and P trigger operation is. We will go through the scan operand for positive signal edge in the Siemens information system. In here you can use the scan operand for positive signal edge instruction to determine if there is a 0 to 1 change in the signal state of a specific operand. We call the operand 1. The instruction compares the current signal state of operand 1 with the signal state of the previous scan, which is saved in an edge memory bit we call operand 2. If the instruction detects a change in the result of logic operation from 0 to 1, there is a positive rising edge. I think this is quite confusing, so I have prepared something for you. This is the input signal edge, the input signal. We use the I0.0 and we have the edge memory bit. The edge memory bit here goes together with the input signal. The edge memory bit is the reference point now. So it is used to compare to the later input signal. In the beginning, the input signal is not set to 1, so it is 0, and the edge memory bit will remember that at the first the input signal is 0, but when the input signal is set to 1, so in case we press a push button or a sensor is working, the input signal goes to 1, and at this time the edge memory bit will compare itself, or the system instruction will compare the edge memory bit to the current input signal. If there is a change from 0 to 1, a rising edge pops up in the output signal. You can see here, and the output signal will last for 1 scan cycle in milliseconds. It's really fast. We can't even know that it happens. Let's take an example with a before I show you the simulation of this scene, I would like to show you the program first. Here I use a push button as a start button with a normally open contact, and we have a light as an output. We have a screen to display the counter when I start to push the button. You can see how it behaves. And the second group, okay, I will change this one. We will talk about the P trigger later. as I mentioned, we have a rising edge memory bit. So we can normally we don't care much about this bit because it is used for the internal operation. We must not use the same memory bit for other operation. One operation we have to use one as memory bit only. Alright. And then now we start our simulation here. I need to compile again. Alright, in the first group we will push the start button, and here we can see when we push and keep the start button, the light will be on as long as we still keep the start button down. When we release the start button, the light is off. Yeah, because it's normally open tag, so we make it close and the output of the light is close, and that's why the light is on. And why we push a lot of numbers increasing? Yeah, because when we push and keep, there are a lot of scan cycle happens. So in here, after each scan cycle, it will add 1 to the results. So that's why after so many scan cycles, the number increasing a lot. Okay, I think this group is really easy to understand, and we go to the second group with the P operation, the rising edge. Okay, now I will start to press and release, press, release. And here we have the start button, we have the light, we have the screen, and we have another light here. We can see at the program the rising edge operation here. When I start to press, the output signal will go to 1 just for a scan cycle in milliseconds. In here we don't even see the light 2 is on. Sometimes we can see, but not always. It happens really fast. But we have something here. We have something here. You remember the edge memory bit here? As I said, the memory bit here goes together with the input signal. When the input signal is on, the memory bit is on always. So we can see it I link the memory bit to the light 3 here. I press the start button here. It means the memory bit is on when I start to press this button. When I release, it's off. So this bit is just for internally comparing. You don't need to care much about it. And because after the P operation, the output changed from 0 to 1 really quick, so it only happened in one scan cycle. So that's why each time I press the start button, only one is added to the counter display here. It's really different to the normally open contact here. Oh yeah, you don't need to care about this one. I just make this one to reset the counter display. Alright, and now we will continue with the P trigger to know what is the difference between the P operation and P trigger operation. I will delete this one or this one. I add the P trigger to here. I use the same memory bit. Alright. Before start the simulation, I want to show you the material for the trigger. In here, you can read all of this one, but the point is the P trigger is applied after a logic. It cannot use by itself only, not like the P operation, not like the rising edge operation. It have to be used after a logic, because it is used after a result of a logic operation, like this. Okay. That's why I put the P trigger after the start too. Now I will start a simulation again. You can see here, the same thing happened. So with a single input signal to the P trigger, we can use it as the P operation as well. But the advantage of P trigger is we can use it with many logic operation, like this. Okay, use another one. All right. Alright, in here you can press this button, and in here you can activate manually. On, off, on, off, on, off. Same thing, but the P trigger you can use with multiple input signals. That is the only difference between the P and P trigger operation. And I think that's it. If you have any question, just comment below, or this lesson is really hard to understand, you can comment below as well. I will explain it to you. Thank you.